Hello students and welcome to yet another video on foundation course for business statistics. So in this video we are going to look at another central tendency, which is median. We have already seen at mode, we have already seen at average, right? So basically there are three types of central tendencies, three measures of central tendencies: mean, median, mode. Mean is also called as average, which we have seen. And now let's see what median is. So what median is? The median is the positional average. So what does that really mean? So if I will take an example here. Suppose I have 2, 5, 1, 6, and 8 as series of numbers, and there are total n is equal to 5, so there are total 5 numbers. Then to find the median of this series, what do we need to do is we have to arrange this series either into ascending order or into descending order. So in this case I am arranging it in ascending order. So I get 1, 2, 5, 6, and 8. Now what is that I need to do? After arranging it into ascending order, I have to find what is the position of median. So how do I find that? I have to do n plus 1 by 2, which is 5 plus 1, where n is 1 by 2, that is equal to 3. So my third element is median. Third element is median, so which is nothing but 5. So for this series, my median is 5. Okay, so you could immediately see that there are equal number of observations that lie on the either side. So two observations are lying on the left side of 5, and another two observations are lying on the other side of 5, which is the right side of 5. So there are equal number of observations lying on the either side of a median, and median is 5. This is known as positional average. And why it is known as positional average? Because we have not done any kind of arithmetic calculations here. Okay, so this is how we calculate the median. uh, Median is straightforwardly calculated when n is odd, when it is no problem. For in this case it was 5 and 5 is odd. But when n is even, basically what you need to do is you need to take an arithmetic mean of two middle values, and we'll see the example of this in another slide. In next slide, yes, we have another example of odd. So let us quickly go through it. So we have 2, 11, 10, 9, 6 is the series set of data elements. We sorted it in the ascending order, and all that we had done was n plus 1 by 2, n is 5. So we got third 3, and my third element is again median, which is 9. So two element on the left, two element on the right. So median is 9. What if n is even? So this is an example. We have n is equal to 6. We have sorted. Always remember to sort the data series given. I have seen students who often forget this very critical step. They just pick up the data set and immediately start applying the formula 1 plus n plus 1 by 2, and then they do a mistake because the position element is wrong. So after sorting, okay, I need to apply my position element. So 6 plus 1 by 2 is what I would get, because n is equal to 6, and this is 7 by 2, which is 3.5. So 3.5, this is the first element, this is second element, this is third element, and this is fourth element. So what I have to do is I have to take third and fourth element, because 3.5 lies between 3 and 4. So I have to take third and fourth element, which is 7, and I have to add them and divide it by 2. So I'm actually taking arithmetic mean of these two elements, which comes out to be 16. 16 by 2 is 8. So in this case, my median is 8. So I have taken arithmetic mean of middle two elements. And why two elements? Because there are equal number of elements on the left side, which is 2, and equal number of elements on the right side. So always take middle two elements when my n is even, whereas when n it is odd, it is very easy, you get a middle one element only. Next, let's find it out when we have discrete frequency distribution. And if you don't know what data type discrete means, or if you don't know what frequency distribution is, I advise you to quickly go through my previous videos on data classification and frequency distribution. So I'm assuming here you have gone through that. So let's quickly go through the problem statement. So we have basically a frequency distribution table, and in that frequency distribution, we have number of accidents and number of shifts, right? So, for example, we have zero number of accidents in two shifts. We have one number of accident in nine shift, so on and so forth. So if I take total, if I take sigma f total of number of shifts, that is equal to 24. Hence, my n in this case is 24. Now, how to calculate cumulative frequency? Simple. For the first row, it is 2. For the second row, I'm going to add 9 plus 2, that is 11. For the third row, I'm going to add 11 plus 8, right? That is 19. 19 plus 4 is 24, and 23 plus 1 is 24. 19 plus 4 is 23, and 23 plus 1 is 24. Okay, so this is how I calculated my frequency, cumulative frequency. And this cumulative frequency is of what type? It is of type less than or equal to cumulative frequency. Again, if you don't understand what cumulative frequency CF is and how to calculate that, I suggest you look at the video which will exactly tell you how to calculate cumulative frequency. Okay, moving forward, let's take n is equal to 24, and so we have 24 plus 1, that is 25. 25 divided by 2 is 12.5. So I have to find out where does my 12.5 number lies in cumulative frequency. So my 12.5 number lies in between 11 and 19, right? So I have to take this class, this particular row, okay, I have to consider, okay, and this, for this position becomes my median value. So number of accident here is 2. So my median in this case is 2. So this is how I calculate median for discrete frequency distribution. Okay, since 12.5 rise in between 11 and 19, I should be taking the next class, the next cumulative frequency greater than cumulative frequency. I will not take 11. Always I will be taking greater than or equal to in this case. So 11 is less than 12.5, whereas 12.5 is, whereas 19 is greater than or equal to 12.5. Yes, 19 is greater than, and hence I take this row for my median, right? So let's move on to next slide. Okay, we have seen currently discrete frequency distribution. So let's see grouped frequency distribution. So this is basically a grouped frequency distribution. And looking at the classes, if you could understand, students, what type of class this is. Yes, your guess is right. This is basically a exclusive type class, right? Because there are no gaps in between two classes. So what do we do? So whenever you find a grouped frequency distribution for which you have to calculate median, now your formula to calculate positional position changes. Till now, both for normal series as well as for discrete frequency distribution, we had n plus 1 by 2. When it is grouped frequency distribution, it becomes n by 2. Okay, so what is the total number of, how will I calculate my n? N is nothing but sigma f, which is equal to 30. So in this case, my n is equal to 30, hence n by 2 is equal to 15, right? Now I have to find out my uh, row, okay, where basically where my cumulative frequency lies, the cumulative frequency which I am looking for. So this n by 2 is 15. No, so we find here 1, 2, yeah, this is where I have found, because as I said, we are looking at greater than or equal to. So 15 is greater than or equal to 15. Yes, it is. And this becomes my row, positional row. Okay, so my median will occur somewhere in this particular, somewhere in this particular group, but I don't know exactly where it is. So for that, I need to apply a formula. So I have found a class, okay, where my median is, but I don't know exactly what my median is. So I need to apply a formula, and that formula is L plus H by F multiplied by N by 2 minus C. So what that really is, what is my L? My L is lower limit of median. So my lower limit of median is 19.5, right? Because my positional row is that for that class is 19.5 plus what is my H? H is class interval. What is my class interval? 14.5 minus 9.5, which is 5. What is the frequency? What is the frequency of my current row which I have identified? It is that frequency is 6. So frequency is 6 multiplied by 30 by 2 minus. Now what is this C? Now C is cumulative frequency of the class preceding the median. Preceding the median of the class preceding the median. So this is my median class, and what is my preceding median class? 14.5 to 19.5. And what is the cumulative frequency of that? It is 9. So this is 9. So 19.5 plus 5 by 6 divided by 15 minus 9. 15 minus 9 comes out to be 6. 6. So 19.5 plus 5 by 6 multiplied by 6, these two gets cancelled. So 19.5 plus 5 is nothing but 24.5. This is how I calculate the median for grouped frequency distribution. Remember this formula. I'm writing once again: L plus H by F into n by 2 minus C, where L is the lower limit of uh, median class, H is the class interval, F is the frequency of median class, N is the number of elements, that is sigma F, minus C. C is the frequency of the preceding class. So this is 5. Preceding class is 14.5 to 19.5. So this is how we calculate. Okay. Also, frequently I have seen the mistake done by most of the students, and they forget in this case it is n by 2 and not n plus 1 by 2. Yeah. With this, we come to the end of this video. We have seen what median is. In next video, we will see what mode is. Thank you so much.